It is the one constant in every human life that has ever been lived, the sun. It is our celestial anchor, our source of light, warmth, and energy. Its rising and setting is the fundamental rhythm of our world, the clockwork that has governed the evolution of all life on Earth for over 4 billion years. It is so reliable, so permanent, that we take its presence for granted. But what if it were not permanent? What if, through some impossible godlike act of cosmic vandalism, our sun did not explode or die, but simply vanished? In one single silent instant, it ceased to exist. Tonight, we explore this ultimate, terrifying thought experiment. We will stand on the Earth and watch as our star disappears from the universe, and we will follow our orphaned world on its final, cold, and dark journey into the void. This is the story of the end of our world. We begin. The event itself is instantaneous and absolute. At the very center of our solar system, the star that contains 99.8% of all the mass in the system is gone. The colossal, gravitational anchor that holds all the planets in their orbits has vanished. The thermonuclear furnace that bathes our world in light and warmth has been extinguished. At the location where the sun once was, there is now only a perfect, cold, and empty vacuum. The greatest catastrophe in the history of our planet has just occurred, and on Earth, for a time we would notice absolutely nothing at all. For 8 minutes and 20 seconds, everything would continue as normal. The sky would be blue, the sun would be shining, the birds would be singing, children would be playing in parks, and life would go on in a state of perfect, blissful ignorance. Our planet, and everyone on it, would be living on borrowed time, completely unaware that our star was already gone. This eerie 8-minute delay is not a matter of chance. It is a fundamental consequence of the laws of the universe itself. It is a deception caused by the ultimate cosmic speed limit, the speed of light. Light does not travel instantaneously. It travels at a blistering but finite speed of approximately 300,000 kilometers, or 186,000 miles, per second. The Earth orbits the Sun at an average distance of 150 million kilometers. A simple calculation tells us that it takes the light from the Sun about 8 minutes and 20 seconds to cross this distance and reach our eyes. This means that we are never seeing the Sun as it is right now. We are always seeing it as it was over 8 minutes ago. We are constantly looking at a ghost, a delayed image from the past. When the Sun vanishes, its last dying rays of light are already on their way to us. For 8 minutes and 20 seconds, we would continue to see the sun in the sky, a phantom image, completely unaware that the source of that light no longer exists. But the deception goes even deeper than that. It is not just the light that is delayed. According to Albert Einstein's theory of general relativity, the force of gravity also travels at the speed of light. Gravity is not an instantaneous magical pull. It is a curvature in the fabric of space-time, and any change in that curvature, like the sudden disappearance of a massive object, propagates outward as a gravitational wave, a ripple in space-time that travels at light speed. This means that for those 8 minutes and 20 seconds, the Earth would not just remain sunlit, it would also remain in its orbit. We would continue to be held in the gravitational embrace of a star that was no longer there. Our planet would be faithfully following the curve in space-time that the Sun had created 8 minutes prior. We would be orbiting a gravitational ghost. Imagine a thunderstorm. You see the flash of lightning in the sky, and then, several seconds later, you hear the roll of thunder. You know that the lightning and the thunder were created at the same moment, but because light travels so much faster than sound, you perceive the event in 2 stages. The vanishing of the sun would be the ultimate version of this phenomenon. The disappearance of its light and the disappearance of its gravity are 2 effects that are born at the same instant, and they travel towards us at the exact same speed. So, for 8 minutes and 20 seconds, humanity would continue its daily life under a sun that was a phantom, and in the grip of a gravity that was an echo. It would be a final, fleeting, and deceptive period of peace, a cosmic quiet before the storm. It is the final gift of time from a universe that is about to unleash an apocalypse of absolute darkness and cold. The 8 minutes and 20 seconds of borrowed time are up. The last photon of light and the last graviton of force from our now vanished sun have just completed their 150 million kilometer journey and have arrived at Earth. The moment of reckoning is here, and it would be a moment of 2 distinct and simultaneous cataclysms, one of light and one of gravity. The first cataclysm would be the final sunset, but it would be unlike any sunset in human history. The sun would not slowly dip below the horizon, it would not fade, it would not linger. For the half of the earth that was facing the sun, the star would simply switch off. In one single immeasurable instant, the brilliant, life-giving disk in the sky would vanish, as if a cosmic light switch had been flicked. The blue sky would be replaced, in the blink of an eye, with the perfect star-filled blackness of the interplanetary void. The transition would be shocking and absolute. One moment you are walking in the bright light of a summer afternoon. The next, you are plunged into a darkness far deeper than any moonless night. The only sources of light would be the distant cold stars, the faint glow of the planets, and the artificial lights of our own civilization. For the cities on the day side of the earth, it would be as if noon and midnight had occurred at the exact same moment. The second cataclysm, happening at the exact same instant, would be gravitational. At the moment the final photon arrives, so does the final ripple of the sun's gravitational influence. The curvature in space-time that has held our planet in a stable, nearly circular orbit for 4.5 billion years suddenly flattens out. The invisible gravitational rope that tethered us to the sun is cut. The Earth would no longer be in orbit. It would now be following Newton's first law of motion. An object in motion stays in motion in a straight line unless acted upon by an outside force. Our planet, which was moving at a speed of 30 kilometers per second, or 67,000 miles per hour, in its orbit, would now continue to travel at that incredible speed, but in a perfectly straight line. We would fly off into the cosmos on a tangential path, like a stone being released from a slingshot. Our planet has now become a rogue planet, an orphan world, untethered from any star, destined to wander the cold, dark, and empty void of interstellar space for what will likely be the rest of time. The moon would, for a time, remain our loyal companion. It is caught within Earth's own gravitational well, and it would be carried along with us on this new, lonely journey. But we would lose our view of it almost immediately. The moon does not produce its own light. It only shines by reflecting the light of the sun. With the sun gone, the moon would become a dark, invisible specter in the sky, its presence betrayed only when it passed in front of a distant star, a phenomenon known as an occultation. Within a single, terrifying instant, our entire reality has been rewritten. Our source of light is gone. Our source of heat is gone, and our gravitational anchor is gone. We are a ship that has had its engine turned off, its lights extinguished, and its anchor chain snapped, all at the same moment. We are now adrift on a dark and infinite ocean, and the long, cold night is just beginning. In the first minutes following the Great Vanishing, the primary experience for humanity would be one of profound shock and confusion. For the half of the world plunged into sudden darkness, there would be mass panic. Power grids, not designed for such an instantaneous and total increase in demand, would likely fail, plunging even our cities into a deeper darkness. For the half of the world that was already in night, the first sign would be the sudden disappearance of the moon from the sky, followed by the dawning, terrifying realization that the sun was not going to rise. But as the initial shock wears off, the first and most profound biological consequence of the sun's disappearance would already be underway. The engine of nearly all life on Earth, the miraculous process that converts light into life, would have ground to a halt. Photosynthesis would have stopped. Photosynthesis is the foundation of our planet's ecosystem. It is a beautiful piece of biochemistry where plants, algae, and some bacteria use the energy from sunlight to convert carbon dioxide and water into sugars, the energy-rich molecules that power their own lives and the lives of almost every other creature on the planet. Every blade of grass, every giant sequoia, every microscopic plankton in the ocean is a tiny solar-powered factory. The moment the sun vanishes, these factories would shut down. Across the entire planet, in a single silent instant, the great chemical engine of life would be extinguished. For the plants themselves, this is not an immediate death sentence. They have energy reserves and can survive in the dark for a time, for days or even weeks. But for the entire global food web, the consequences would be immediate and catastrophic. The oxygen we breathe is a byproduct of photosynthesis. While the Earth's atmosphere contains a vast reservoir of oxygen, enough to last for thousands of years for the surviving animal life, the production of new oxygen would cease. We would, from this moment on, be living on borrowed air. The immediate and most devastating impact would be on the microscopic world of the oceans. The phytoplankton, tiny single-celled organisms that float in the sunlit upper layers of the ocean, are the true lungs of our planet. They produce more than half of the world's oxygen and form the absolute base of the entire marine food web. With the sun gone, these trillions of microscopic plants would die off in a matter of days. The consequences would cascade up the food chain with terrifying speed. The tiny zooplankton that feed on the phytoplankton would starve. The small fish that feed on the zooplankton would starve. The larger fish, the marine mammals, the seabirds, the entire complex and beautiful tapestry of ocean life would begin to unravel from the bottom up. The great dying would begin in the sea. On land, the immediate effects would be slower, but just as certain. Herbivores would continue to eat the existing plants for a time, but with no new plant growth, this food source would be finite. The great cycles of nature, which have been powered by the steady, reliable input of solar energy for billions of years, have been broken. In this first hour of darkness, another, more physical change would begin to make itself felt. The temperature would begin to drop. With no sunlight to warm the surface, the Earth would now only be radiating its own stored heat away into the cold, black emptiness of space. The Great Freeze has begun. The first hour marks the end of the age of biological creation. The planet is now living on borrowed time and borrowed warmth. As the hours of darkness tick by, the second great consequence of our star's disappearance begins to take hold: the catastrophic loss of heat. Our planet is, in essence, a large, solid rock that has been sitting in front of a colossal fire for 4.5 billion years. The surface of that rock has been warmed to a comfortable, life-sustaining temperature. Now the fire has been extinguished. The rock, our planet, will now begin to shed its stored heat into the perfect, near absolute zero cold of empty space. The Great Freeze is accelerating. After 24 hours of absolute darkness, the change in temperature across the globe would be dramatic and undeniable. The global average surface temperature, which is normally about 15 degrees Celsius or 59 degrees Fahrenheit, would have plummeted to about 0 degrees Celsius or 32 degrees Fahrenheit, the freezing point of water. Of course, this drop would not be uniform. The deserts, with their lack of insulating water vapor and cloud cover, would have cooled much faster, their temperatures dropping to well below freezing within hours. The coastal regions and areas with high humidity would have cooled more slowly, as the water vapor in the atmosphere would have trapped some of the outgoing heat, a final, fleeting greenhouse effect. But by the end of the first day, almost all of the planet's land surface would be at or below the freezing point. For the plants and animals of the world, this would be a thermal apocalypse. The great tropical rainforests, which have never experienced a frost, would be devastated. The leaves of the trees would freeze and shatter. Countless species of insects, reptiles and amphibians, not adapted to the cold, would perish. The great migrations of birds and land animals would become pointless, as there would be no warmer lands to flee to. The entire planet is becoming a freezer. Humanity would be thrown into a desperate battle for survival. The immediate and most pressing need would be for heat. Our power grids, already strained by the sudden demand for light, would now be pushed to the breaking point by the demand for electric heating. Widespread blackouts would be inevitable. People would turn to burning wood, coal, and natural gas, any source of fuel to fight off the encroaching planetary cold. But these are finite resources. The social order would likely begin to break down as billions of people scrambled for the last remaining sources of warmth and food. The only humans with a real long-term chance of survival would be those living in communities powered by sources independent of the sun and the surface, primarily geothermal energy and nuclear power. The people of Iceland, for example, who derive a significant portion of their heating and electricity from the geothermal heat of the Earth's crust, would be at a significant advantage. So would the crews of nuclear-powered submarines, who are already living in a self-contained, artificially lit world, powered by a tiny man-made star. By the end of this first, terrible day, the Earth has become a different planet. The surface is freezing over, the food chains are collapsing, and humanity is facing its greatest ever challenge. We are no longer living on a vibrant, sunlit world. We are now the desperate inhabitants of a dying, freezing rock, flying through the dark at 67,000 miles per hour. After 7 days of darkness, the Great Freeze has tightened its grip on our orphaned planet. The global average surface temperature has now dropped to a brutal -17 degrees Celsius, or about 0 degrees Fahrenheit. The land masses of our world are now completely frozen wastelands, scoured by winds that are no longer driven by the sun, but by the last, lingering temperature differences between the land and the still warm oceans. This week marks the beginning of the end for the planet's most significant feature, its liquid water. The oceans have begun to freeze. The freezing of the oceans would not be an instantaneous event. It would begin at the surface. A thin, transparent sheet of ice would start to form, first in the polar regions in the calmer coastal waters, and then spreading rapidly across the entire globe. Within a few weeks, the entire surface of every ocean on Earth would be covered in a solid layer of ice. This initial freezing would have a profound and, for a time, a protective effect. Water has a very unusual and very lucky property. Its solid form, ice, is less dense than its liquid form. This is why ice cubes float. As the ice layer forms on the surface of the oceans, it would act as a colossal, planetary-scale insulator. It would be like putting a lid on a pot of warm water. This ice lid would dramatically slow the rate at which the deep ocean could radiate its immense stored heat away into space. Beneath this growing sheet of ice, the deep ocean would remain liquid for a very, very long time, for hundreds of thousands of years. The sheer thermal inertia of the oceans is immense. The top few meters of the ocean contain as much heat as the entire atmosphere. The deep ocean is a vast reservoir of warmth that will take an almost unimaginable amount of time to cool down. But for the surface world, the freezing of the oceans marks the end of the water cycle, and therefore the end of all weather as we know it. With the oceans covered in ice, water can no longer evaporate into the atmosphere. With no evaporation, there can be no clouds. With no clouds, there can be no rain or snow. The planet-spanning blizzards that raged during the first week would slowly die down as the last of the moisture precipitates out of the atmosphere. The sky would become permanently, unnaturally, and terrifyingly clear. On the surface of the frozen dead Earth, you would now be able to see the stars with a clarity that no human has ever witnessed. With no atmosphere full of water vapor, no city lights, and no dust, the band of the Milky Way would blaze across the sky with a brilliant, fierce light. The sky would be a magnificent but cold and uncaring spectacle. For humanity, the freezing of the oceans means the loss of our greatest resource. The fishing industries would be gone. Global trade, which relies on shipping lanes, would have ceased. The climate patterns that have shaped our civilizations would be a distant memory. The last remaining survivors would be huddled in their geothermal or nuclear-powered shelters, now living not just on a dark planet, but on a world that is becoming a solid ball of ice. The gentle blue and white marble we once knew is now a gray, frozen, and silent sphere, its surface scarred by the frozen remains of its once mighty oceans. 1 year has passed since the Great Vanishing. 365 days of absolute darkness. Our planet has now traveled nearly 1 trillion kilometers, or over 600 billion miles, from its original orbit, journeying in a straight line out into the interstellar void. It has become a true rogue planet, and in this year of darkness, it has transformed into a world that would be almost unrecognizable to us. The Great Freeze has reached a new and more extreme stage. The average surface temperature has now plummeted to about -100 degrees Celsius, or -150 degrees Fahrenheit. At this temperature, the very air we breathe begins to change its state. The atmosphere itself has begun to freeze. The first component of the atmosphere to go would be the carbon dioxide. At a temperature of about -78 degrees Celsius, carbon dioxide gas turns directly into a solid in a process called deposition. It would begin to snow-dry ice. A fine, glittering carbon dioxide snow would fall from the clear black sky, blanketing the already frozen water ice of the oceans in a new, exotic layer of frost. As the temperature continues to drop over the next few centuries, even the main component of our atmosphere, nitrogen, will begin to condense into a liquid and then freeze into a solid. The Earth would eventually be covered in a global, miles-thick layer of frozen nitrogen snow. The atmosphere we once knew, the great ocean of air, would be gone, its substance now a solid part of the planet's frozen surface. The only gas remaining would be a very thin, tenuous wisp of the elements that are hardest to freeze, like neon and helium. The surface pressure on Earth would have dropped to near zero. It would be a vacuum. Our planet is now in a state of deep and almost perfect cryostasis. The surface is a silent, static, and unimaginably cold wasteland. There is no wind. There is no weather. There is no sound. The only thing that ever happens on the surface is the very slow accumulation of this atmospheric snow. Geologically, the planet would also begin to shut down. The process of plate tectonics, the slow movement of the continents, is driven by the heat from the Earth's mantle. While this internal heat is still present, the freezing of the surface and the oceans would have a profound effect. The crust would become thicker, more rigid, and less mobile. Earthquakes and volcanic eruptions would become less and less frequent over the next few millennia, as the planet's geological engine slowly cools and seizes up. For any surviving humans in their subterranean shelters, the world outside would now be more alien and more hostile than the surface of Mars or the Moon. It would be an airless, cryogenically frozen world, bathed only in the faint, cold light of the distant stars. But this state of cryostasis is also a state of perfect preservation, with no atmosphere, no liquid water, and no geological activity to erode them. The cities and monuments of our civilization would be preserved, frozen in time under a blanket of nitrogen snow. They would become a silent, archaeological record of a world that once was, a frozen museum of a species that was once warmed by a star. This frozen Earth would continue its long, silent journey through the galaxy, a dark and lonely tombstone carrying the perfectly preserved remains of a lost world. The surface of our orphaned Earth is now a sterile, frozen, and airless wasteland. All life that depended on the sun, from the smallest plant to the largest animal, is long extinct. The great global biosphere is gone. And yet, this may not be the end of the story of life on Earth. In the deepest, darkest, and most hidden corners of our world, in realms that have never seen the sun, life could endure. There are two primary havens where the last survivors might cling to existence for billions of years to come, powered not by the light of a star, but by the faint, residual warmth of the planet's own core. The first of these havens is the deep ocean. While the surface of the seas has frozen into an ice cap that is now kilometers thick, the deep ocean remains liquid. The immense volume of water and the insulating power of the ice shell above mean that the deep sea will take billions of years to freeze solid. And at the very bottom of this dark, cold, liquid ocean, there are oases of life-giving energy. These are the hydrothermal vents. Hydrothermal vents are fissures in the seafloor, particularly along mid-ocean ridges, where geothermally heated water erupts from the Earth's crust. This water is superheated to hundreds of degrees and is rich in dissolved chemicals like hydrogen sulfide and methane. This chemical cocktail is a source of energy, and there are entire ecosystems of organisms, from microbes to giant tube worms and blind crabs, that have evolved to live off this chemical energy in a process called chemosynthesis. These hydrothermal vent ecosystems are completely independent of the sun. Their energy comes from the heat of the Earth itself. The disappearance of the sun would have almost no effect on them. They would continue to thrive in their dark, high-pressure world, completely unaware that the world above them had died. For these creatures, life would go on. In fact, these deep-sea oases might be the true cradles of life, the places where biology first arose on Earth, and they would be the last places where it would survive. They would be the final flickering embers of life in a world that had gone cold. The second great haven for life lies even deeper, within the rock of the Earth's crust itself. For decades, we have been discovering that life exists in places we once thought were sterile. There is a vast, deep biosphere of microbial life, bacteria and archaea, that lives in the tiny pores and fissures of rocks, kilometers beneath the surface. This life is also completely independent of the sun. It survives on a starvation diet, metabolizing chemicals that seep up from the Earth's mantle, like hydrogen and methane, or even just feeding on the slow radioactive decay of elements in the rock itself. These are the ultimate extremophiles, organisms that live on geological timescales, with metabolic rates so slow that they might only reproduce once every 1,000 years. The death of the sun would be a complete non-event for this deep biosphere. Shielded by kilometers of rock from the freezing surface, their slow, patient, and dark existence would continue, unchanged, for billions of years, until the Earth's core itself finally cools and the last of the geothermal energy fades away. This deep life represents the ultimate resilience of biology, a quiet and persistent spark buried deep within the rock of our wandering dead planet. While the microbes of the deep Earth and the tube worms of the hydrothermal vents could survive the end of the sun with ease, what about humanity? Could our own species, with all its intelligence, technology, and ingenuity, possibly find a way to survive on a world plunged into an eternal freezing night? The answer is a qualified and very grim, perhaps. Survival would be possible, but it would require a feat of engineering and societal reorganization so immense that it would be the single greatest challenge in the history of our species. It would be humanity's final desperate stand. Our only hope would be to follow the lead of the extremophiles and go deep. The surface of the planet would be an uninhabitable, airless, and cryogenically frozen wasteland. Our only refuge would be underground or under the sea, in self-sustaining habitats powered by the only reliable energy source left, geothermal heat of the Earth. We would need to build vast subterranean or sub-oceanic cities, deep enough to be insulated from the killing cold of the surface. These habitats would have to be perfect, closed-loop ecosystems, capable of recycling all air, water, and waste for thousands, or even millions of years. The most logical place to build such cities would be in regions of high geothermal activity, like Iceland, or the volcanic rift zones at the bottom of the ocean. Here, we could drill deep into the crust to tap into the planet's immense reservoir of heat. This geothermal energy would be our new sun. It would power our lights, run our life support systems, and most importantly, allow us to grow food. We would have to create vast underground hydroponic farms, illuminated by powerful electric lamps, all powered by the heat of the Earth. We would become a species that lives on nuclear and geothermal power alone. Our entire civilization, a fragile, artificial bubble of warmth and light, carved out of the deep, cold rock. The engineering challenges would be monumental. We would need to build these habitats and transfer a significant portion of the human population to them before the surface became completely uninhabitable, a process that would likely take decades. The social and psychological challenges would be just as great. Humanity would be transformed from a surface-dwelling, sun-loving species into a race of subterranean cave dwellers. We would live our entire lives without ever seeing a blue sky or feeling the warmth of a star. Our art, our culture, and our psychology would be forever changed by this new claustrophobic existence. But perhaps the greatest challenge would be resource limitation. While our geothermal energy supply would be vast, the physical resources needed to maintain a complex technological civilization are not metals, minerals, and other raw materials would have to be mined from the surrounding rock. These resources are finite. Over the millennia, our subterranean civilization would be a slow-motion replay of our surface civilization's story of resource depletion, but this time with nowhere else to go. Humanity's final stand would be a long, slow, and difficult one. It is possible that we could survive as a species for a very long time, perhaps for millions of years, huddled around the dying embers of our planet's core, but it would be a diminished existence, a long twilight autumn for a species that was once born to the sun. We would be the last intelligent survivors on a rogue planet, the lonely caretakers of a magnificent tomb, telling stories of a time when our world was a warm, blue, and sunlit paradise. For any remnant of humanity huddled in the deep earth, and for the extremophile life in the lightless oceans, a new and almost unchanging reality has set in. The Earth is no longer a planet in the conventional sense. It is a starless world, an orphan, a rogue planet on a long and lonely journey through the vast dark ocean of the Milky Way galaxy. The dramatic, chaotic events of the first few years are over. Now begins an age of profound, silent, and almost eternal travel. Our planet, released from its solar orbit, is now a ship with its engines off, gliding through space in a perfectly straight line at a speed of 30 kilometers every second. This trajectory is a cosmic fingerprint, a straight-line memory of the exact moment in our orbit when the sun vanished. We are now traveling out of the familiar stellar neighborhood, and as the millennia turn into millions of years, the very sky above us will transform. For the first few tens of thousands of years, the view would remain somewhat familiar. Our former sun would still be a bright, prominent star in the sky, though it would be steadily dimming as we moved away. The constellations of our night sky, the patterns that have guided human civilization for all of its history, would begin to warp and distort. The individual stars that make up these patterns are all moving in their own directions, and our own motion through the galaxy would create a dramatic parallax effect. The Big Dipper would stretch. Orion would be dismembered. The sky would become an unfamiliar tapestry of lights. After 1,000,000 years, our sun would have faded to the point where it would be just another anonymous star in the sky, its special significance lost to all but the most precise astronomical measurements. We would have traveled about 1,000 light-years from our starting point, a significant journey. but still a tiny step within our 100,000 light-year wide galaxy. We would still be deep within our local spiral arm, the Orion arm. The journey would be one of incredible loneliness. The average distance between stars in our part of the galaxy is about 5 light-years. This means that for most of our multi-million-year journey, our rogue Earth would be in the profound emptiness of interstellar space. It would be a solitary wanderer, its passage marked only by the slow, almost imperceptible shifting of the distant cold stars. The planet itself would settle into a deep cryogenic equilibrium. The thick layers of frozen atmosphere on its surface would insulate the planet's core, allowing its geothermal heat to leak out at an incredibly slow rate. The deep subsurface oceans, powered by this geothermal heat, could remain liquid for billions of years. In this dark, stable, and unchanging environment, the life around the hydrothermal vents could continue to evolve, completely unaware of the cosmic journey it was on. It is a strange and beautiful thought. A world dead on its surface could be carrying a secret, thriving biosphere on a multi-billion-year tour of the entire galaxy. This long journey is the final state for our world. It has become a self-contained, geothermally powered oasis, a dark ship carrying the last remnants of terrestrial life on an endless voyage. But the galaxy is not entirely empty, and over a long enough timescale, even the loneliest journey can be interrupted by a chance encounter. For millions and perhaps billions of years, a rogue Earth could travel through the interstellar medium in relative peace. But the galaxy is a dynamic and sometimes violent place. The void between the stars is not truly empty, and our orphaned world would inevitably face new hazards on its long, dark journey. One of the first potential encounters would be with a giant molecular cloud. These are the vast, cold, and dense nurseries where new stars are born. As our planet silently drifted into one of these colossal clouds of gas and dust, its environment would change dramatically. The view of the distant stars would be extinguished, blocked by the opaque gas of the nebula. The planet would be flying through a dense cosmic fog. This would have a physical effect on the planet. The gas and dust of the nebula, as tenuous as it is, would create a form of interstellar drag, ever so slightly slowing the planet's velocity. More significantly, the planet's own gravity would begin to accrete, or pull in, some of this gas, primarily hydrogen and helium. Over a long passage through a dense cloud, the Earth could begin to accumulate a new, thin, primordial atmosphere. This new atmosphere would not be breathable, but it would change the pressure and chemistry of the planet's frozen surface. A far more violent and dramatic encounter would be with a nearby supernova explosion. If a massive star within a few dozen light-years of our passing Earth were to end its life in a supernova, our world would be hit by a wave of unimaginable energy. A brilliant flash of light, brighter than a billion suns, would briefly illuminate our frozen planet, followed by a ferocious blast of high-energy particles and a colossal, expanding shockwave of gas. This shockwave, moving at a fraction of the speed of light, would slam into our world. It could be powerful enough to sandblast away the layers of frozen atmosphere that have accumulated on the surface. The intense radiation would be of little consequence to the deeply buried life in the oceans, but it would fundamentally alter the surface chemistry of our planet. Our world would be a silent witness to the most powerful and creative acts of destruction in the cosmos. The most profound encounter of all, however, would be a close pass with another star system. While the chances are slim, over a billion-year timescale, they are not zero. As our rogue Earth drifted close to another star, the star's gravity would capture it and pull it into its system. Our planet's long, straight-line journey would be over. It would now be caught in a new chaotic orbit around a new star. This encounter would likely be a violent one. Our Earth would be a gravitational billiard ball, careening through a new and possibly populated solar system. It could disrupt the orbits of the existing planets, trigger a new storm of asteroids and comets, or even collide with another world. It would be an intruder, a dark and frozen ghost from another sun, bringing chaos to a new and unsuspecting home. The long, quiet journey of our rogue planet could end in a final, spectacular, and destructive gravitational dance. The most tantalizing and the most unlikely of all the fates that could befall our wandering Earth is the possibility of finding a new home. Could our orphaned world, after a journey of billions of years through the cold and the dark, be gravitationally captured by another star, becoming a true planet once more? The answer is a slim, but not impossible, maybe. The physics of gravitational capture are notoriously difficult. For one object to capture another into a stable orbit, there needs to be a way to shed the incoming object's excess energy. A simple two-body interaction, a rogue Earth and a single isolated star, would almost always result in a flyby, with our planet entering the system and then swinging back out again on a hyperbolic path. For a capture to be possible, a third body is usually required. Imagine our Earth passing through a binary star system. The complex gravitational dance between our planet and the two stars could, if the geometry is just right, allow our Earth to transfer some of its kinetic energy to one of the stars, allowing it to settle into a stable, albeit likely strange and eccentric, orbit. Or, if the star has a large, Jupiter-like planet, our Earth could have a gravitational interaction with that planet, again shedding enough energy to become a new captured member of the system. Let's imagine this 1 in a trillion chance occurs. Our Earth is captured by a new sun-like star. What would happen next? The long, deep freeze would be over. As our planet settled into its new orbit, it would once again be bathed in the light and warmth of a star. The process of thawing would begin. The first layers to go would be the most volatile, the frozen nitrogen and carbon dioxide snow that blankets the surface. As the planet warmed, these would sublimate directly back into a gas, recreating a thick, dense atmosphere. This new atmosphere would be, for a time, a crushing, unbreathable mixture of nitrogen and carbon dioxide, creating a powerful greenhouse effect that would dramatically accelerate the planet's warming. Then, the great water ice sheets would begin to melt. This would be a process of unimaginable geological violence. The melting of glaciers kilometers thick would trigger colossal, planet-spanning floods. The continents would be reshaped. The very crust of the planet, now freed from the immense weight of the ice, would begin to rebound in a process called isostatic rebound, triggering massive global earthquakes. Eventually, after a few centuries of this chaotic thawing, the planet might settle into a new equilibrium. It might once again have liquid water oceans. It might once again have a stable climate. But would it be a paradise reborn? Almost certainly not. The thick carbon dioxide-rich atmosphere would likely have created a runaway greenhouse effect, turning the planet into a scorching Venus-like world far too hot for life as we know it. And what of the life that survived in the deep ocean? The sudden reheating of the planet and the dramatic change in ocean chemistry would be a profound shock to an ecosystem that had evolved in the cold and the dark for billions of years. It might trigger a new evolutionary explosion, or it might be a final fatal cataclysm that wipes out the last, most resilient vestiges of terrestrial life. The dream of a second chance, of finding a new sun and being reborn, is a powerful one. But the reality is that our planet, after billions of years as a rogue, would be a fundamentally changed and alien world. Even if it were to find a new home, it would likely never again be the gentle, blue, and life-giving paradise it once was. We have followed our orphaned planet on its final, hypothetical journey. We stood on its surface during the eerie 8-minute deception, and we witnessed the final instant sunset that plunged our world into an eternal night. We watched as the great freeze took hold, as the oceans turned to ice, and as the very atmosphere fell as snow, entombing our world in a state of perfect cryogenic preservation. We saw how life, in its incredible resilience, might cling to existence in the deep geothermally heated oceans. And we have followed our planet on its billion-year odyssey through the galaxy, a dark and lonely tombstone on an endless voyage. This thought experiment, as terrifying as it is ultimately a story about the sun. It is a journey into the darkness that is designed to make us appreciate the light. We are so accustomed to the sun's presence that we forget that it is the single driving force behind almost everything that makes our world what it is. The sun is the engine of our climate, the power source for our biosphere, the anchor of our orbit, and the clock that sets the rhythm of our lives. Its light is the energy that fuels the entire food chain, from the smallest plankton to the largest whale. Its heat keeps our oceans liquid and our atmosphere a gas. Its steady, reliable presence has provided the stable conditions necessary for life to evolve and flourish for billions of years. To imagine the sun vanishing is to perform a kind of cosmic subtraction, to remove the central variable from the equation of our world and see what remains. And what remains is a stark and powerful lesson in our own dependence, our own fragility. We are children of the sun. In the most literal sense, our bodies, our societies, and our entire world are built for and utterly dependent on its constant, life-giving light. The good news is that our sun is not going to vanish. It is a stable, middle-aged star with another 5 billion years of life ahead of it. But the value of this journey is not in its prediction of a real event. It is in the perspective it offers. It allows us to step outside of our daily experience and see our world for what it truly is, a precious, fragile, and incredibly lucky oasis of warmth and light in a universe that is, for the most part, profoundly cold, dark, and empty. To know the darkness is to truly and deeply appreciate the dawn.